In this video, we are going to look at the graph of the cosine function. So we're going to start with just the most basic parent function, y equal cosine x. When I look at y equal cosine x, there are specific angles that are most significant for me. So if we remember, the cosine is the x value of each angle on the unit circle. So if I look at the most important angles for me, if I look at say x equals 0, then my cosine x is going to be 1 because I'm looking at the x value of the angle 0. But y equal cosine x means that my y value is going to be 1. If I look at my next angle, that's going to be pi over 2. The cosine of pi over 2 is 0. So my y value is 0. If I look at my next angle, I'm looking at the angle x equal pi, which means that my x value is -1, my cosine is -1, so I get a y of -1. The next angle that is particularly important for me is 3 pi over 2. Here we're looking at down here. The cosine of 3 pi over 2 is 0, so we get a y value of 0. And then finally, we go to 2 pi, which gets us back to a y value, an x value. A cosine of 2 pi is 1, so we get a y of 1. Now we have some points to plot, and we can plot those points. So 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1, and we connect that with a sinusoidal curve, which looks something like this, and it continues forever in either direction. If we think about this graph, we have a domain of -infinity to infinity, because I can plug in any value onto the unit circle, and a range that goes from -1 to 1, because we're looking at the x values on the unit circle, which means we go from -1 to 1. The period is 2 pi, because after we've gone 2 pi around the circle, we're back where we started. You can also see that if you think from looking at the distance from peak to peak. And my zeros take on the form pi over 2 plus pi k comma 0 for any integer k. So if k is 0, this gives me the 0 pi over 2 comma 0. If k is 1, this gives me the integer 3 pi over 2 comma 0. If k is -1, this gives me the 0 negative pi over 2 comma 0. If k is 300, this gives me the integer, the 0 601 pi over 2 comma 0. So any k I plug in, any integer value of k I plug in will give me another 0. And that gives me the cosine function. But usually our cosine function is going to be a little bit more complicated than just y equal cosine x. Usually we will have things along the lines of y equals some amplitude times the cosine of some horizontal stretch times x minus some horizontal shift plus a vertical shift. So we can stretch and shift both horizontally and vertically. Let's look at a specific example. Let's look at the example y equals 1/2 cosine 2 times x minus pi over 2 minus 1/2. If I look at this example, then we're going to build a table. And in my table, I'm eventually going to need to figure out the y values. But before I figure out the y values, I need to come up with the angles that matter the most for me. And those angles really don't ever change. They're going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so I need to figure out when I get to those angles. So I need x minus pi over 2 gets multiplied by 2 in my function. So I need x minus pi over 2 to be 0. That happens when x minus pi over 2 is 0. When x minus pi over 2 is pi over 4, then when I multiply it by 2, I get pi over 2. When x minus pi over 2 is pi over 2, multiplying that by 2 gets me to pi. If I look at x minus pi over 2 being equal to 3 pi over 4, then when I multiply that by 2, I get 3 pi over 2. Or when x minus pi over 2 is equal to pi, multiplying that by 2 gets me to 2 pi. So I need to figure out what x values get me there. So to get to 0, to get me to where x minus pi over 2 is 0, x needs to be pi over 2. To get to where x minus pi over 2 is pi over 4, x needs to be 3 pi over 4. If I want x minus pi over 2 to equal pi over 2, x needs to be pi. If I want x minus pi over 2 to be 3 pi over 4, then x needs to be 5 pi over 4. And if I want x minus pi over 2 to be equal to pi, then I need x to be equal to 3 pi over 2. And the y values, when my angle is 0, my cosine is 1, so y is 1. When my angle is pi over 2, my cosine is 0, so I get a y is 0. When my angle is pi, my cosine is negative 1, so y is negative 1. When my angle is 3 pi over 2, cosine of 3 pi over 2 is 0. When my angle is 2 pi, cosine of 2 pi is 1. Now, each of those is going to be multiplied by 1/2, so I'll take care of that in a moment, but let's just graph those points for the moment. If I look at those points, I'm looking at the point pi over 2 comma 1. That's this point. I'm looking at 3 pi over 4 comma 0. That's that point. Pi comma negative 1. That's that point. 3 pi over 4 comma 0. That's that point. 3 pi over 2 comma 1 gets me that point. And then I'm multiplying that by 1/2, so the zeros stay the same, but the points that are at x equal 1 become, if this will do its thing, the points at 1 become points at 1/2. And the points down here at negative 1 become points at negative 1/2. And I can go ahead and continue the pattern of points out like this. And then this whole thing is being moved down by 1/2. The minus 1/2 at the end moves the whole thing down by 1/2. So if I take that whole thing and I move it down by 1/2, I'm left with these points that I just now have to draw the appropriate graph for. And of course, that continues forever in each direction. And that is the graph of y equal 1/2 cosine 2 times x minus pi over 2 minus 1/2. It has a domain of negative infinity to infinity. My range is, because of the multiplication by 1/2, it's only half as tall. Moving down by 1/2 means that my range goes from -1 to 0. My period, well, because I multiplied by 2, my period shrunk to half its original size. So instead of 2 pi, my period is pi. You can also see that by looking from peak to peak or valley to valley. And you can see that from 0 to pi, I got from valley to valley. So my period is pi. And then my zeros for this particular function are occurring at pi over 2 plus k pi, comma 0, because they're occurring at the peaks. And that is my the graph of the function y equal 1/2 cosine 2 times x minus pi over 2 minus 1/2.